National Electrical Code, specifically Article 240.109b, addresses the installation height of shunt trip devices. A shunt trip is a mechanism that electrically trips a circuit breaker. According to the NEC, the shunt trip device shall be located not more than 450 mm, which is equivalent to 18 inches above the floor. This requirement is designed to ensure accessibility for operation and maintenance. Several factors contribute to the need for this specific height restriction. Firstly, accessibility is paramount. Electrical equipment needs to be readily accessible to qualified personnel for inspection, testing, and maintenance. Placing the shunt trip at a reasonable height ensures that electricians and other authorized individuals can easily reach and operate the device without the need for ladders or other cumbersome equipment. This reduces the risk of accidents and speeds up the process of troubleshooting and repairs. Secondly, safety is a critical consideration. Electrical systems can be hazardous if not properly installed and maintained. By setting a maximum height for the shunt trip, the NEC helps to minimize the potential for electrical shock or other injuries. A lower mounting height means that the device is less likely to be located in areas where accidental contact is more probable, especially in environments where there may be standing water or other conductive materials. Thirdly, standardization is crucial for consistency and ease of use. The NEC aims to standardize electrical installations across different locations and applications. By specifying a maximum height for shunt trips, the code ensures that electricians working in various environments can expect to find these devices in a consistent location. This uniformity simplifies training, reduces errors, and promotes overall safety. In practical terms, the 18-inch height restriction means that shunt trip devices should be mounted relatively low on the electrical panel or enclosure. This typically involves positioning the device near the bottom of the enclosure, where it is easily accessible from the floor. Electricians should carefully measure and verify the mounting height during installation to ensure compliance with the NEC. Failure to adhere to this requirement can result in code violations and potential safety hazards. The importance of the shunt trip function should also be understood. A shunt trip is designed to remotely or automatically open a circuit breaker in response to a specific electrical signal. This signal can come from a variety of sources, such as a fire alarm system, an emergency stop button, or other protective devices. When the shunt trip receives the signal, it instantly trips the circuit breaker, cutting off power to the connected circuits. This is particularly useful in situations where it is necessary to quickly de-energize electrical equipment to prevent further damage or injury. Common applications of shunt trips include industrial facilities, commercial buildings, and data centers. In industrial settings, shunt trips are often used to shut down machinery in the event of a malfunction or emergency. In commercial buildings, they may be connected to fire alarm systems to automatically disconnect power to non-essential circuits during a fire. In data centers, shunt trips can be used to quickly isolate electrical faults and prevent downtime. The NEC requirement for shunt trip height is just one of many provisions aimed at ensuring the safe and reliable operation of electrical systems. Electricians and electrical contractors should be thoroughly familiar with all applicable code requirements and follow them carefully during installation and maintenance. This includes not only the height restriction for shunt trips but also other relevant provisions related to wiring, grounding, overcurrent protection, and equipment labeling. Proper electrical installation is essential for protecting people and property from electrical hazards. Ignoring code requirements can lead to serious consequences, including electrical fires, shocks, and equipment damage. Therefore, it is crucial to take the time to understand and comply with the NEC. In addition to the NEC, local electrical codes may also have specific requirements for shunt trip installations. These local codes may be more stringent than the NEC in some cases, so it is important to check with the local authorities to ensure compliance with all applicable regulations. The NEC is updated on a regular basis to reflect changes in technology and best practices. Electricians should stay up to date with the latest edition of the NEC and any relevant amendments or interpretations. This can be accomplished by attending training courses, reading industry publications, and consulting with experienced electrical professionals. Continuous learning is essential for maintaining competence and ensuring that electrical work is performed safely and in accordance with the latest standards. When installing a shunt trip, it is important to select a device that is appropriate for the specific application. Shunt trips are available in various voltage and current ratings, and it is essential to choose a device that is compatible with the circuit breaker and the control system. The shunt trip should also be listed by a recognized testing laboratory, such as Underwriters Laboratories, to ensure that it meets applicable safety standards. The installation of a shunt trip should be performed by a qualified electrician who is familiar with the NEC and other relevant codes and standards. The electrician should carefully follow the manufacturer's instructions for installation and wiring, and should verify that the device is functioning properly after installation. The electrician should also provide documentation of the installation, including the date of installation, the model number of the shunt trip, and the results of any testing performed. Regular inspection and maintenance of shunt trips are essential for ensuring their continued reliability. Shunt trips should be inspected periodically for signs of damage or corrosion, and should be tested to verify that they are functioning properly. Any damaged or malfunctioning shunt trip should be replaced immediately. The testing of shunt trips can be performed using a variety of methods, including manual testing and automated testing. Manual testing involves manually activating the shunt trip and verifying that the circuit breaker trips. Automated testing involves using specialized equipment to automatically test the shunt trip and record the results. The selection of the appropriate testing method depends on the specific application and the available resources. In conclusion, the NEC requirement for shunt trip height is an important safety provision that helps to ensure the accessibility and reliability of these devices. Electricians should be thoroughly familiar with this requirement and follow it carefully during installation and maintenance. By adhering to the NEC and other relevant codes and standards, electricians can help to protect people and property from electrical hazards. Remember that the 18-inch maximum height is crucial for compliance and safety. When working with electrical systems, safety should always be the top priority. Electricians should wear appropriate personal protective equipment, such as gloves and safety glasses, and should follow lockout/tagout procedures to de-energize circuits before working on them. Electricians should also be aware of the potential hazards associated with electrical work, such as electrical shock and arc flash, and should take steps to minimize these risks. It's important to note that the NEC is not a design guide. It provides minimum safety requirements, but it does not specify how to design an electrical system. Electrical engineers are responsible for designing electrical systems that meet the specific needs of a particular application. The NEC provides a framework for ensuring that these designs are safe and compliant with applicable codes and standards. The NEC is a complex document, and it can be difficult to interpret some of the provisions. Electricians and electrical engineers should consult with experienced professionals or the local electrical inspector if they have any questions about the NEC. The local electrical inspector is responsible for enforcing the NEC and other local electrical codes. The inspector can provide guidance on how to comply with these codes and can help to resolve any disputes that may arise. The NEC is constantly evolving to reflect changes in technology and best practices. Electricians and electrical engineers should stay up to date with the latest edition of the NEC and any relevant amendments or interpretations. This can be accomplished by attending training courses, reading industry publications, and consulting with experienced electrical professionals. Continuing education is essential for maintaining competence and ensuring that electrical work is performed safely and in accordance with the latest standards. In addition to the NEC, there are other standards and guidelines that may be relevant to the installation of shunt trips. These include standards published by organizations such as the Institute of Electrical and Electronics Engineers (IEE) and the National Fire Protection Association (NFPA). These standards provide additional guidance on topics such as grounding, bonding, and overcurrent protection. The selection of the appropriate shunt trip for a particular application depends on a number of factors, including the voltage and current rating of the circuit breaker, the type of control system, and the environmental conditions. Shunt trips are available in various configurations, including single-pole and multi-pole versions. The configuration of the shunt trip should be compatible with the circuit breaker and the control system. The environmental conditions should also be considered when selecting a shunt trip. Some shunt trips are designed for use in harsh environments, such as those with high temperatures or humidity. The shunt trip should be selected to withstand the environmental conditions in which it will be used. The installation of a shunt trip should be performed in accordance with the manufacturer's instructions. The instructions should be followed carefully to ensure that the shunt trip is installed correctly and that it will function properly. The wiring of the shunt trip should be performed by a qualified electrician. The electrician should use the correct wiring methods and materials and should ensure that all connections are properly made. The shunt trip should be tested after installation to verify that it is functioning properly. The testing should be performed in accordance with the manufacturer's instructions. The testing should verify that the shunt trip will trip the circuit breaker when activated. The shunt trip should be inspected and tested periodically to ensure that it is functioning properly. The inspection and testing should be performed in accordance with the manufacturer's instructions. The inspection and testing should verify that the shunt trip is free of damage and that it will trip the circuit breaker when activated. Any damaged or malfunctioning shunt trip should be replaced immediately. The replacement shunt trip should be of the same type and rating as the original shunt trip. The replacement shunt trip should be installed in accordance with the manufacturer's instructions. The installation of a shunt trip is a critical safety function. The shunt trip provides a means of remotely tripping a circuit breaker, which can be used to protect personnel and equipment from electrical hazards. The shunt trip should be installed and maintained in accordance with the NEC and other applicable codes and standards. Remember the critical 18-inch maximum height for the shunt trip installation as per NEC 240.109b. Always consult the latest edition of the NEC and local codes for the most current requirements.